Good day. Now we're going to start Unit 3.1. Actually, we're starting Module 3. This is going to be an entirely new topic. We're going to be talking about endothermic and exothermic reactions in the next few chapters. So everything you've seen in secondary 3 and 4 will kind of be repeated, but we're going to go a few steps further. So we're going to go more in depth about reactions that absorb energy, reactions that release energy, why that is, and how this happens, and so on and so forth. So 3.1 is very simple. It's an introduction. Basically, we will explain the difference between heat and temperature. Very often we use the two terms, we alternate heat and temperature as if they mean one thing, but actually they don't. Heat is the amount of thermal energy that gets transferred between two bodies that are at different temperatures. For example, if you put your hands around a hot cup of coffee or chocolate, very often in the winter, for example, your hands are going to be very cold. So that cup of coffee or hot chocolate will give heat to your hands. So the physical transfer of energy between the two bodies, the cup itself and your hands, that's called heat. Temperature is the measurement of the amount of thermal agitation, so the kinetic energy within a system. So we're not looking at two systems at that point, we're just looking at one and how much movement there is within the particles, within that actual system that we're looking at. Now the minimum amount of energy that there can be is 0. So at 0 Kelvin, which is also called absolute zero, there is basically no agitation. Your particles stop moving. Now this temperature has never been reached, but they got very close to it, and what they've observed is that in fact particles practically don't vibrate anymore, but they're still trying to always reach it. They think that in theory particles would stop moving, and even some scientists go further and they say that matter would cease to exist because it would stop moving, it would have no volume, and so on and so forth. But again, it's never been reached, so we're not sure. So temperature only is related to only one substance as opposed to heat, which is the transfer of thermal energy between two substances. Now, heat always travels from something hot to something cold, never the reverse. So something cold doesn't have enough energy, so it cannot give any, obviously. So it's the body that's hotter, that has most energy, that will give to the other body that's lacking energy. And by the way, something cold, when we say something is cold, it doesn't really exist. Really what it is that an object or a substance has a lack of heat, but it's not cold per se. Cold is not a state. It's again a lack of energy. So energy will always flow from hot to cold until both bodies have exactly the same temperature, so the same amount of movement of kinetic energy. Now, if I give you a little example here on how this applies, I have a container. It has a certain amount of, again, if we look at our definitions, it will have a certain temperature, so a certain amount of kinetic energy in there. I also have a thermometer that has a certain amount of kinetic energy, so the alcohol in here, the particles are moving at a certain speed, have a certain amount of collisions and whatnot, so it has a certain amount of kinetic energy. Now, it's not necessarily the same, right? So if I take my thermometer and I put it into my solution, well, at that point, there will be, because they're not at the same temperature, there will be an exchange of heat between the two of them. So let's pretend that my solution is hotter. So the energy will be transferred from hot to cold. So from the solution into the thermometer. And this is going to happen through collisions. My particles here, because they're hotter, the temperature is higher, they have more kinetic energy, they move more, they collide more. And all those collisions with the thermometer actually transfer a little bit of that energy to the particles inside the thermometer. Now these get more and more excited, they start moving faster, they start colliding more, and what happens at that point? Well, the fluid inside expands, and that's why you get a higher reading on the thermometer than initially when it was outside the container at a lower temperature. Now, if I did the opposite, let's pretend I have another container here and I have cold water in it. I even have ice cubes. Okay. Now, if I take my thermometer and I transfer it back into here where the ice cubes are. Now, in this case, at that point, the thermometer is a little warmer, not a little, but very much warmer than the cold water. So at that point, we're going to use another color. At that point, the heat is coming, in this case, from the thermometer. So it's being transferred to the beaker in which I find cold water. So the heat is coming from here, going into the cold water. So by doing that, the energy is being transferred into the water, and therefore the alcohol in the thermometer is losing energy. The particles are slowing down, and because they're slowing down, they're colliding less, and the fluid inside, the alcohol, is compressing. And that's why your temperature, your reading, becomes lower in the thermometer. So again, all that to illustrate that your energy is always flowing from hot to cold and not the reverse. And there's an exchange when you have two substances at two different temperatures, so with two different amounts of kinetic energy, they will exchange heat until the two temperatures, the two amounts of kinetic energy are equal, and the same for both bodies, both substances. So again, here I'm going to be repeating myself. When you feel something cold, it's not that it's actually cold, it's because there's a lack of heat. So heat, in this case, if we look at the example, is being transferred away from the hand into the ice cube. So the ice cube is very cold, the hand is pretty warm, right, relatively speaking. So your hand is going to give some heat to the ice cube, which causes it to melt at the same time. And it leaves your hand with a sensation of cold because it's really lowering its temperature. That's why when you hold a piece of ice in your hand, it's really, really cold. It's freezing your hand. The same way if you're chewing on gum that is mint flavored, you feel as if you have a sensation of freshness in your mouth. Why? Because again, the reaction, basically what it's doing is that the gum is absorbing some heat from your mouth because it's endothermic. So it's taking away energy and heat from your mouth, lowering the temperature inside your mouth, and you have therefore that feeling of freshness from the mint. So there you go. This was 3.1, very short and sweet. So temperature between heat, between heat and temperature. So there you go, you have it. Now you're going to go to class and answer a few questions on this. Hopefully you understood the concept and you'll be able to move to 3.2. Ciao, see you next time.